In this video, I will teach you all the MongoDB aggregations. The basic queries are fine, but when you're transitioning from SQL, you might feel limited by the simplistic way to query items. That's until you learn that those simple queries are overshadowed by aggregations. Think of them like a big conveyor belt where each aggregation does something to the data. If you ask me, I would categorize those aggregations into three parts. Essential aggregations required to transform the data in the ways you want. Complementary aggregations required as well, but for much easier tasks. Modifier aggregations, those that modify data, not to just read it. We'll start with essential aggregations first. Number one is match. This works like the find function and it lets you query objects based on different criteria. Every object that you pass in the find function can be passed in the match aggregation. This can be simple criteria like the property equals value, much complex criteria like greater than, less than, or regex. You can work with arrays. In the first line, we match the property number of cats with any item from the 1, 2, 3, 4, 5 array. And in the second line, we match every record where the first item of the array previous jobs exists, meaning the array is not empty. Finally, you can query by conditional criteria. In the first line, we have the not operator, matching every candidate where the number of kids is not 3. In the second line, we use the are operator to query every candidate where the property number of cats is either 2 or 3. In the third line, we use the and operator to match the candidate that has age of 20 and gender of male. If you're thinking that this AND operator matches the default behavior of the match aggregations, you will be right. Honestly, AND is a bit redundant sometimes. Next is projection. If match filtered the data we queried, projection transforms it. The main use case is creating new fields, restructuring existing ones, or most importantly, choose not to query them. Choosing to not query some large fields will greatly increase your website speed, especially if you have lots of objects. Now that I've convinced you that choosing not to query all fields is a good practice, here are two ways to do it. You can either specify what fields to query and everything else will be excluded, or you can specify which fields will be excluded and you'll query everything but them. Next use case for the project aggregation is renaming fields. You can see here that I renamed _ID to just ID without the underscore, age to years of life, and favorite color from being spelled with an U to being spelled without it. Last case is creating new fields. The most common one is to get the length of an array property and make the value a new property. But you can do things like concat array or create if-else statements that return different values based on different criteria. As an extra point, project can do a lot of things and get overwhelming, so you can split those things in set or addFields, they're basically the same thing, to add fields to the data, or unset to take fields from the data. As an extra point, you can use the replaceRoot instead of projection for simpler aggregation. Instead of writing each subchild by hand, you can just replace the root object with one of its properties and you're good to go. Next is group, one of the most powerful aggregations. It's used to group a collection by any property, letting you create demographics and segment data, like the hot babes in your area. You can do lots of things with those segmented collections, but first, here's how you can segment. Use the _ID property to specify which field you want to use to segment the data. This will become the new identifier of data. In this example, the data will be segmented by city, with the values like New York and Boston. In this other example, the segmenting is done by age, with values like 18, 19, and 20. Now keep in mind that you are not limited to segment only by one value. For example, here we group records by age and city, the result being every possible combination of the age and city where records were found. Now you can go much granular with your grouping. But we haven't even gotten to the fun part, transforming the records that fall into those segments. Here are 8 things you can do with the data from the segments. First, we can count all the documents in that segment. This adds 1 for each candidate in that city, effectively counting them. Next, we can sum a property from all the documents in that segment. We use the sum operator to add all the number of cats from each person in that city, and we get it here. Next, we can get the average of a number of a property in that segment. By using the AVG operator on the age property, we get the average age for that city. Next, we can get all the documents in that segment. Using the $$ root operator and the push operator, we can push the whole initial object into the array. Next, we can return all the documents in that segment, but use the projection learned previously to only get the necessary data. Next, we can only return the first document in that segment. We again use the $$ root operator, but this time with the $ first, the first document in that segment. Next is fetch all the values of a specific field, or lastly, you can do other crazy stuff that's outside the scope of this video, like conditional sums. If after all of that group feels kind of limited, enter its big brother bucket. Bucket lets you group data based on broader scopes. Unlike group, you can query data like segment products by price in 200 increments. The group by is the equivalent of the ID property in group, so basically it's for specifying the property to segment the data. Boundaries are the values to segment by in ascending order. Default is the default value, And in output, you can specify other operations to be done with your data, just like you would do with a group aggregation. And then the output looks like this. You can also query data by segment candidates that have the name start, A to F, F to O, O to Z, or segment candidates registered by month, etc. So aside for some different naming conventions, group and bucket are very similar. You can of course combine the addFields, cond, and group together to achieve the same thing, but you end up with more fields, more work, and frankly bucket is way cooler. Now that you've learned bucket and group, why not learn their total opposite, unwind? Where group segments data and groups it, unwind does the opposite. If the candidate had an array property animals with 2 animals inside, when you unwind it, you will receive 2 equal objects with only the animals property being different, being just an object from the array. You can include the index with the include array index property, the value of it being the name of the new property. Then you can use preserve null and empty arrays to tell Mongo what happens if the value specified in the path is missing. Set to true if you want to keep the null values as well, or set to false, which is the default, if you want to unwind only the records that have the value not null. You might struggle to find use cases for unwind, but I've used this hundreds of times in combination with group to filter and group the data even more. One more use case for this is using it in combination with lookup, which is the next aggregation. Now before moving to the simple aggregations, let's talk about lookup. Lookup functions just like the outer left join in SQL, i.e. uses an ID in the current table to search in another one. It's very useful when you want to get the parent or the children object of another one. The lookup aggregation has a simpler and more complex variation depending on your workflow. The simple one is straightforward, having only 4 parameters. The from parameter specifies the name of the collection you want to join. The location field specifies the field of the current table that corresponds to the joint table. The foreign field specifies the field in the joint table. And the s specifies the name of the property that will store the result. The result will be an array even if it's just one item. I usually use the unwind function to make it an object. But if you feel that this aggregation has more potential, you're right. The more complex variation lets you specify variables. These variables get used in nested aggregation pipeline running in the animals table, and the result will be stored in the s value. Be careful of the syntax needed to use the variables in the let property. In match, you need to use the x aggregation and use the double signs to reference your let variables. And believe me, you can run any other aggregation pipeline inside the lookup like sort, limit, project, and count. But with great power comes great responsibility. Most of the slow queries I found myself creating used this nested lookup pattern. You search for children of an object without realizing that with every object found you are running another aggregation. So optimization is crucial here. Make sure you do the following things if you find your queries taking too long. The fields you are using in the foreign fields or that you use in the match are indexed. Indexation, while increasing the size of the database, greatly increases the speed of querying records based on that field. 2. Make sure you move the limit and match before the lookup, effectively doing those joins on fewer records. In the second example, we moved match and limit before lookup, decreasing the number of times it runs to maximum 20. And 3. Opt out for including more info inside the original object. If you are doing a lookup just to get the name, consider having the field in the original table with that value. Just make sure to keep it updated at all times. Okay, so now that you've learned the essential aggregations, we can move to the simple ones. One of them is sort. This is just like the sort function of basic queries. You specify the property you want to sort by, 1 for ascending, -1 for descending, and you can specify as many props, the first ones being the most important. Also, when you use the search aggregation inside match, you can sort by best matches with the meta text score syntax. Another one is limit. This is like the limit function in basic queries. You specify a number and that's the max number of documents you're gonna get. Another one is skip. This is like the skip function in the basic queries. You specify the number and that's how many documents are gonna get skipped from the database. Another one is sample. This lets you query a random set of objects from the database. Just specify the number of objects you want retrieved and they will be queried randomly. And the last one is count. The count aggregation counts all the documents and stores them in a specified property. This will erase all data and just give you the count of all objects. And if you don't want to lose the data, here's the next aggregation. If you want to do more aggregations at the same time, then facet is for you. If you found yourself in the situation that after 2-3 aggregations, you want to use the outputted data in 2 different ways, facet is perfect for that. The result will be a list with an object that will have the parallel aggregation you specified. You can use facet with any other aggregations but these ones. Now the last 2 aggregations are the modifier aggregations and they write to other collections. The caveat here is that they must be the last step in the pipeline. Another caveat is that the collection will be created if it doesn't exist. The first one is out, which writes the output in a collection and overrides it, so all previous data will be erased. There are 2 fields to specify. DB, which is optional and is the database of the to be written collection. If nothing is specified, Mongo will use the DB of the current collection. The call is the collection the output will be written in. Keep in mind that you can also use out in time series collections. Now merge is out on steroids minus the ability to write to time series. Its simplest form looks like this, and you just specify the collection to merge with. By default, merge doesn't overwrite the collection it writes in. If the to be inserted document already exists, it keeps the new fields and overwrites existing ones. If it doesn't exist, it just creates a new one. But you can easily overwrite this functionality in the expanded version of merge. If the document is found, you can replace, keep existing, merge, fail, or pipeline. Default is merge, and the other options are self-explanatory. The pipeline option is outside the scope of this video. If the document is not found, you can either insert it, discard it, or fail the aggregation. Also, to finish explaining all the fields in the expanded version, into is the new collection you want to write in, and on is the database field to determine whether the operation is an overlap or not. The into field can have an expanded version if you want to output to another database. Merge is very useful for database migrations as you can get very granular with your overriding rules. That's all the MongoDB aggregation in 12 minutes. Now you can say on your resume that you have 2 years of experience with MongoDB aggregations. Mind you, here are some more aggregations to be covered, so hit the like button and leave a comment about it and I'll make sure to cover them next.